postulate, whatever you want to call it, that we're going to deal with is what's called the ruler postulate. And it just says the following, that the points on a line can be matched 1-to-1 with the real numbers. Right? Because isn't a ruler just a number line? What is a number line? A line with numbers on it, right? So a ruler is just a number line with all the numbers spaced out evenly apart from each other. So what a ruler postulate says is I can take any line, right? So here's a line, and I can match points on this number line with the real numbers, right? So I can line it up here, I can line it up here, which is what we normally do. We always usually start at 0, but I could technically still measure it from 5 to 28. Okay, so that's your ruler postulate, which just pretty much tells you that you can use a ruler. That's like a number line. Your coordinate is the real number that corresponds to the point. So the real number that corresponds to the point. And then when we talk about distance, right, what does distance really mean? The distance from one point to the other, which is kind of just like the same thing as the length. So when we go to find distance, why my iPad's not working. We're going to think of distance as being the absolute value of the difference of the coordinates of A and B, where the A and B represents our points. So point A, point B. So quick review. Don't put this in your notes. Just watch. Once you're done writing, look up. So I know you're done. So quick review. In geometry, remember we use symbols to represent something. So what does this represent in words? May, what does this represent in words? How would you say that in words? Line A, B. Good. If I did this, Adam, now what did it become? Ray A, B. Good. And if I did this, James, now what do I have? Line segment A, B. Good. Okay, so remember when we put these symbols above it, those represent different geometric figures. When there is no symbol above it that means something, it means distance. So if I'm looking to find the distance between 2 points, I'm going to list those 2 points. No symbol. So notice that there is no symbol above. So no symbol above means I'm looking for the distance between those 2 points. So everybody got that? Why do I want the distance to be the absolute value of the difference? What does absolute value give us? Adam?
It's typically used finding the distance between that number and 0.
Yeah. What's the absolute value of 5? 5. What's the absolute value of negative 5? 5. Why do I want to take the absolute value of the difference of something when I'm talking about the length of something? Can I have negative lengths? No. So I needed my distance to always be positive. How do I assure that I will have a positive answer? By taking the absolute value of it. Okay, so that's why we do absolute value. All right, so we got distance. We understand what distance is. And let's talk about measurement, which we just did. So we've got inches. So remember on a ruler, when we're doing inches, each of those tick marks, though this picture is pretty bad because it's only eighths. Notice it's 16ths, so 1/16, 2/16, 3/16, 4/16 is a quarter, 5/16, sticking to the board. 6/16 is 3/8. Where are we at? 7/18, 8/18 is a half, 9/18, 10/18 is 5/8, and then so forth, all the way up to 16/16, which would be 1. Okay, so those are inches. The rest of the world uses the metric system, which is a lot easier. I don't know why in America we use inches when it's so much easier to measure in centimeters and millimeters. So we have our centimeters and our millimeters. And the reason why that's nice is we have units of 10. So each tick mark is just a point. Right? 0.1, 0.2, 0.3, 0.4, 0.4, 0.5. Is everybody good? All right. So here we're going to use the ruler postulate to measure the length of line segment, ST, to the nearest tenth of a centimeter. So my ruler postulate says that I can take endpoints of a line segment, match them up with a coordinate on the real number system, and then I can think about distance. So this S is at 2. My T, it looks like I'm at 5.4. Does that look about right on your paper too? So how many units is it to get from 2 to 5.4? Well, we've got 2 options. Me personally, I would just count 1, 2, 3 centimeters plus how many extra points? 4. So the length of ST is equal to 3.4. Mathematically, I could take the absolute value of the difference, so 5.4 minus 2, which is 3.4. Or if I did 2 minus 5.4, I would get negative 3.4. And the absolute value of that is 3.4. Okay, so length. So given a ruler, we can find the lengths. Yeah? Okay, I'm going to skip the measuring part because we just went through that measuring-wise. Is everybody okay with me skipping the measuring part? No feelings are going to be hurt. So let's skip the toothbrush. Let's jump to segment addition. So this is where the stuff gets good. So segment addition. If I said, okay, guys, I'm going to make a line up here that is 10 inches long. That looks a little bit longer. I'm going to estimate that's 12 inches. And then I'm going to add on to that a segment that is 4 inches long. What would be the total length of that whole entire segment, Marley? 16 inches. What did we do? We just added the lengths of segments. Okay, so that's what segment addition is. It's just adding segments together. Now, it does get a little bit fancy, and the important part is we need this when we get to proofs. So when we start doing geometric proofs, segment addition comes into play. So we need to get this formal definition down. So for segment addition, we have if AB, and remember, what does it mean when there's no symbol above? That means I'm talking about the length. So if the length from A to B plus the length from B to C is equal to the length from A to C, then it must be true that B is between A and C. Okay, so what does that look like over as a diagram? I'll give people a second to get caught up, so I'm not rushing them. Okay, so if the length from A to B, so A to B is here, plus the length from B to C is here. So if the blue chunk plus the yellow chunk is equal to the whole green chunk, then B has to be between it. Right? So AB, the length of A to B plus length BC is equal to AC. So it's not very complicated stuff. We're just adding segments together. All right, so let's do our first example here. We need to find the length of MP. Notice I have MP right next to each other, no symbol above. That means I'm being asked to find the distance. Well, MP is from here to here. Who can do that mental math for me really quickly? Yeah, so MP is going to be equal to 5 plus 18, which is 23. Not too crazy, huh? Pretty easy, hopefully. All right. Let's step up our game a little bit here for example number 2. Here we need to find the length from G to H, which is this little sliver right there. Liam, what do you think? What's the length of GH? What are you thinking in your head? So if we have 2 numbers up there, we know that the whole thing is 36. If this section here is 21, what does the green need to be?
15.
Yeah, so we're doing 36 minus 21, which is 15. So there we had the whole length. We were given a part of it. Subtract the difference to get the remaining part. Is everybody good there? Okay, we're going to pause from our notes for a second. Marley?
Same or similar.
The same or similar, right? Which is correct. So it's not going to be exactly quite the same because it's not going to be in the same location, but they will have the same length. So when we talk about congruent segments, we're going to talk about line segments that have the same length. So line segments that have the same length would be congruent segments. If we said equal segments, then they would be exactly on the same location on the board. Congruent segments can be in different positions, but they will have the same length. So over on the right box, let's try to create congruent segments. Let's make one segment here, label it AB, and then directly below it, try to make CD be the same length. So to show that line segments are congruent, so in geometry, we use a whole lot of notations to represent words. To represent congruence, we put these little tick marks. So I'm going to do a single tick mark through each of those lines. When you see those tick marks, that means it's safe to assume that those have the same length. And then you could do double tick marks, you could do triple tick marks to like deviate between all the different congruent segments that you have. Okay? I don't think we've ever had quadruple tick marks, but so if you see tick marks on lines, find the matching tick mark, and then that means it's safe to be congruent. We also have this as notation. So if I wanted to say line segment AB is congruent, so an equal sign with a squiggle on top. Have you seen that before? That means congruent. So line segment AB is congruent to line segment CD. So that's telling me that the line segments are congruent to each other. And what does it mean to have congruent segments? It means to have equal lengths, right? So this is different. If I put AB with no symbol over it, is equal to CD. What that statement's telling me is the length of AB is equal to the length of CD, which could be true. If this is 5 inches and that's 5 inches, then 5 inches does equal 5 inches. So the lengths would be equal, but never, ever, ever do you make line segments equal, unless they're the same line segment laying on top of each other, which in this case it's not. Okay? All right, so let's finish up with the last few examples. Here it says, using the provided ruler, determine whether line segments are congruent or not. What is the length of JK? What do you guys think? Anybody? About 7.5, does it look like?
Yeah.
7.5 units. And then P to K. This is how I would do it. I would do little loops. So 12 to 11 is 1, 2, 3, 4, 5, 6, 7. Looks like that's 7.5 also. So do they have equal measures? Yes. Are they congruent? Yes. So let's write out our notation. So JK, line segment JK, is congruent, so equal sign with a squiggle, to line segment PN, because they have the same length. And then for our last example, There we got all sorts of craziness going. In the diagram, points V, W, X, Y, and Z are collinear. VZ equals 62. XZ equals 30. The length of X, or WX, is equal to the length of XY, which is equal to the length of YZ. And Ben's already started, which I like because he started labeling things. So the first thing I see there is VZ is equal to 62. So I'm going to do a little one of these guys and label that 62 all the way across. XZ is 30. So I'm going to do one of these little guys between X and Z and mark that as 30. So let's do a little bit of thinking. If from X to Z is 30 and V to Z is 62, what would be the length from V to X? 62 minus 30 is, yeah, so that would be 32. So we can do this as like a 32. I don't know if that's going to be helpful or not, but we got that. Okay, so now for this last part here, it tells me that these three lengths have to be equal, which means they have to be congruent. So I'm going to put a tick mark between W and X, tick mark between X and Y, and a tick mark between Y to Z, just to remind myself that those are congruent, which means they're all the same. Well, if from X to Z is 30, and X, Y, and YZ have to be the same, what do each of them have to be? 15, right? So I'm going to do a little 15 here, which then also tells me WX would be 15, because all of them have to be the same. Which then, how can I find V to W? 32 minus 15, which is, what is that, 17?
Yes.
So now I have all the information that I potentially might need to answer the actual question. So notice I didn't even look over here to see what I'm being asked. I have all this over here. So what is the length from WX? Hey, I'm almost done, guys. 15. What's the length of V to X? V to X is, what do we go with? 32. 17 plus 15. V to W, 17. W to Y, 30. Perfect. Good. There it is.